Hi everyone, today we are talking about rational numbers and then how to add and subtract rational numbers. Let's first start off with the definition of rational numbers. So rational numbers, and you should add this to your notes, are numbers that can be expressed in the form a over b or a divided by b, where a and b are integers or positive or negative whole numbers. All that means is that rational numbers are numbers that can be written as a fraction. And a lot of numbers can be written as a fraction. So if you want to put in some examples, 3/8 is a rational number, negative 11/7 is a rational number. So fractions are included. So it includes whole numbers, integers, positive and negative numbers, fractions, most decimals. Okay, so it's basically a lot of the numbers that we see in the real world. And you're probably thinking to yourself, what? Whole numbers? How can they be rational? Well, whole numbers can be written as fractions. So for instance, the number 3, I can just rewrite it as 3 over 1 or 3 ones. And negative 4 can be written as negative 4 over 1 or negative 4 ones. Okay, so that's why rational numbers, you can think about it as an umbrella that includes a lot of the numbers that we've been dealing with. So positive and negative numbers, whole numbers, integers, fractions, and like I said, most decimals, because some decimals can't be rewritten as fractions. You probably will also notice that the word rational has the word ratio in it. And ratios can be written as fractions too because they're comparing two different quantities. Okay, so when we are talking about rational numbers, as you notice, we will be dealing with a lot of fractions. So let's go ahead and review fractions. All right, so like we said, rational numbers include fractions because rational numbers are just numbers that can be written as fractions. So we're going to be reviewing our fractions. We are going to be working with equivalent fractions when we are dealing with adding and subtracting fractions in rational numbers. So as a review, we can see that 3/4, 6/8, and 12/16 are all equivalent fractions. They're equal to each other. They're basically just written in different formats. So 6/8 is really just that 3/4 multiplied by 2 top and bottom, their common factor, to get to 6/8. 3 times 2 and 4 times 2 on the bottom to get to 6/8. Now, why do we multiply by 2 top and bottom? Because 2 over 2 is really equal to 1. So we're really not changing it. We're just doubling the top and the bottom so that it's equivalent. See, this is 1, 2, 3 shaded out of 4. And this is 1, 2, 3, 4, 5, 6 shaded out of 8. So it's really the same amount shaded. We're just cutting the pieces into smaller pieces. Same with 12/16. It's the same amount shaded, 3/4. We're just cutting it into 16th pieces. So it's really 3/4 multiplied by 4 top and bottom. Again, that doesn't change anything because it's really like multiplying by 1 because 4 over 4 is equal to 1. So the amount that we have doesn't change. It's just the size of the pieces. And that's what the denominator tells you. The denominator just tells you the size of the pieces. Okay, so the numerator over the denominator, if you remember, the numerator tells you how much is shaded, how much we're actually talking about, and the denominator just tells you the size of each piece. Okay, so you can have these equivalent fractions, 3/4, 6/8, and 12/16, talking about the same amount shaded, it's just the sizes of the pieces are different. And again, we multiply the top and bottom by the same number to get there, to the equivalent expressions, equivalent ratios. All right, let's talk about adding and subtracting these rational numbers then. And remember, in order to have equivalent fractions, we need the same denominator before we add or subtract. So this is something important for you to write into your notes, okay? We need the same denominator before we add or subtract them. Let's go over some examples then. All right, here's our first example, example 15 from the book. Find the value of -2 1/5 plus -1 1/3, giving your answer in its simplest form. Okay, so first off, we have got to change them into having the common denominator. So I have a fifths here and a third here. The reason we have to do that is because when we talk about fifths, 1, 2, 3, 4, 5, we're talking about pieces that are that big, right? And when we talk about thirds, we're talking about pieces that are that big. So we can't just add them together. We have to change it so that they have common denominators. They're just not equivalent to each other. Now, the trick with mixed numbers is that we do have to change it into an improper fractions first in order to find the common denominator. So a little annoying, but totally doable. Okay, so if I have 2 1/5 and I need to change it into improper fractions, then let me just show you how it would look like, okay? So this is 1 whole. Here is another whole. Okay, so that's 2. And then I'm going to show you 1/5. Okay, I'm going to go ahead and shade in 2. So here's 1 whole shaded in. And then here's 2 wholes shaded in. So I'm shading in all of them because 5/5 is equal to 1, right? So 1 plus 1, so that's 2 wholes, 2 and 1/5. So for this last one, I'm only shading in 1 of the fifths. So this is 2 wholes and 1/5, okay? So if I needed to change it into an improper fraction, all I'm doing now is changing it into, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11/5. And don't forget it's negative, okay? So we're just looking at how many fifths there are, while the mixed number way of saying it groups wholes together and then tells you what's left over, like the remainder that couldn't make up a whole. So you can draw it out to figure out how many total fifths you have, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11/5. Or if you remember from before, there is a shortcut. You can multiply your denominator by a whole number, 5 times 2, and then add the remainder up here, plus 1. So 5 times 2 is 10. 10 plus 1 is 11. So that's your shortcut on how to get to an improper fraction. Okay, and basically it's just 5 times 2 because they're saying, hey, if there's 2 wholes, then there's 5/5 in each whole. So that's how the shortcut works. And then you add the 1 that's remaining. Okay, so with -1 1/3, it's just the same thing. I could draw myself 1 1/3. So here's a 1, and then this will be for my third. And again, I'll shade it in. So here's 1 whole, which is 3 over 3, and then 1/3. So when I'm trying to figure out my improper fraction, it would just be 1, 2, 3, 4/3. Okay, and again, the shortcut is to multiply the denominator by 1. So 3 times 1, and then add that numerator up top because that was our remaining amount that couldn't make a whole. So 3 times 1 is 3, plus 1 is 4. Okay, and again, it's just figuring out how many thirds were in the whole plus the remainder. Okay, and then don't forget your signs. Oh, and your parentheses. So this was a plus, negative 4/3. Okay, so we changed it into an improper fraction. Now let's create or figure out what the common denominator is. I have fifths and I have thirds. What's the common denominator there? The least common multiple. Well, least common multiple would be 15 because 5 and 3 can both multiply to get to 15. Okay, so 5 would multiply by 3. Remember top and bottom to keep it equivalent. And the 3 would multiply by 5, top and bottom, right? Because multiplying by 5 top and bottom is really multiplying by 5 over 5, which is 1, or 3 over 3, which is 1. Okay, so now I multiply negative 11 by 3, so I get negative 33 on top, 5 times 3 on the bottom, so I get 15 on the bottom, plus negative, don't forget that sign, 4 times 5 on the top, 20, and 3 times 5 on the bottom, which is 15. So now they have equivalent or the same denominator, the common denominator. Now I can add or subtract them together because I have pieces that are the same size. Because remember, before I had fifths compared to thirds. The thirds are much bigger pieces. So now they're equivalent pieces, and now I can add them together. So I'm going to keep the denominator the same, and then I'm going to do the math with the top. I have negative 33 plus negative 20. They're the same sign, so I'm going to add them together, 33 plus 20, to get 53. Okay? And they're both negative, so I keep the sign. And there we go. We have negative 53/15. But we're not done yet because we got to change it back into a mixed number. So I'm just going to figure out how many times 15 goes into 53. 53 divided by 15 is 3-ish. Goes in evenly 3 times at least. Okay. So let's see. 15 goes in evenly 3 times. 15 times 3 is 45. So this is 13 minus 5, which is 8. So I have a remainder of 8. Don't worry about the remainder. I'm just going to turn it into a fraction. Okay, so it goes in evenly 3 times. Remember, it's negative with a remainder of 8. And remember, it's over 15ths. Okay, because remember, it's how many times it goes in evenly, and then your remainder becomes that fraction. So our answer is negative 3 and 8/15. Lots of work. We got to change it to an improper, then find the least common multiple for the denominator, and then remember we have to change it back to a mixed number. All right, here's another example. You need to find the value of 7/8 minus negative 11/4 plus negative 1/3, giving your answer in its simplest form, meaning you need to simplify any fractions you have at the end. Go ahead and pause the video and try it on your own first. All right, there's a lot going on here. But you know what? My first step before I do anything is I'm going to change it or simplify these signs, okay? So first off, I have 7/8, and then I have a minus negative 11/4. So I have 2 negatives next to each other. We've talked about this in our video on adding and subtracting integers, that subtracting a negative is the same as adding. So let's go ahead and change this sign over here into a plus already. So we're going to add 11/4, and then adding a negative is the same as subtracting. So let's go ahead and simplify that already. Okay, that looks so much better because there was a lot of like unnecessary stuff there to confuse us. Negative and negative is positive, so we changed that already. Positive and negative is negative. We got that changed already. This looks a little bit easier to do. Okay, and then remember, for fractions, these rational numbers, we need to have the same denominator, a common denominator, before we can add or subtract them. So we're looking for a least common multiple between 4, 8, and 3. So let's see, how could we do that? Well, I'm thinking, let's go through the multiples of 8, okay? So there's 8, there's 16, there's 24, and there's 32, and I'll stop there. Do all of them go into 8? No, 3 doesn't go into 8. Do all of them go into 16? Nope, 3 doesn't. Do all of them go into 24? Yes, that does work. So their least common multiple is 24. 8 would need to multiply by 3 to get to 24, and remember top and bottom. 4 would multiply by 6 to get to 24. And then 3, you would need to multiply by 8, remember top and bottom, to get to 24. Okay, so we got our least common multiple, and then we know what to multiply to get to our common denominator. So let's go ahead and do that. 7 times 3 is 21 over 24. All of them will be over 24, 24ths. Okay, so let me go ahead and write that. Top is 6 times 11, which is 66, and then this top is 8 times 1, which is 8. All right, now that we have the same denominator, we can do the math on top. So we have 21 plus 66 minus 8. So that's 79. So we have 79 24ths. And it's positive because we just did the math in the calculator. 21 plus 66 minus 8. It was a positive 79 at the end. And remember, it's 24ths. Okay, and remember, we need to change it into a mixed number and in its simplest form. So let's see how many times 24 goes into 79. That's 3 times with some remainder left over. So let's see how much remainder. 3 times. 4 times 3 is 12. Add the 1. 3 times 2 is 6 plus 1, so it's 7. 9 minus 2 is 7. So we have a remainder of 7. Remember, we're taking that remainder and we are changing it into a fraction. So this should be 3 and 7 24ths. Can I reduce 7 and 24 anymore? No, 7's a prime number, so we're done there. The answer is 3 and 7 24ths.